Now we're given two equations here, so we'll simplify each of them. So the first one, log xy square base a equals to p. So this we will use this is a product, so we use the logarithm rule. So a product implies that the individual product terms, we can express the logarithm form into as a sum. So log x base a plus log y square base a. So simplifying, log x base a with the power 2, just bring down in front to multiply. So plus 2 log y base a equals to p. Now that will be the first equation. So the second equation is similar, but this time around you see a quotient form. So something divided by something, x squared divided by y cubed. So quotient form, the logarithmic terms will be in the difference. So log x squared over y cubed base a equals to q. Log x squared base a difference, so minus log y cubed base a, and this equals to q. So bring down the powers, the index here, 2 for the x squared and 3 for the y cubed, bring down to multiply. So 2 log x base a minus 3 log y base a equals to q. That will be the second equation. So we can do simultaneous on these two equations to simplify log y base a and log x base a terms in terms of p and q. So let's use 2 times of equation 1 to subtract equation 2. 2 times of equation 1 would mean this one multiplied by 2, right? Both left and right side of the equation. So 2 log x base a plus 4 log y base a minus equation 2, so minus 2 log x base a, and minus 2 times and 3, a negative times negative 3, so we plus 3 log y base a equals to 2p, because 2 times of equation 1 minus equation 2, so the right side is q, 2p minus q. Simplifying, there's no more log x term, so 4 plus 3, 7 log y base a equals to 2p minus q. So my log y base a would be 2p minus q over 7. Putting in equation 3 into any of the equation to solve log x base a. So I put into equation 1. So my log x base a plus 2 times log y base a. So log y base a, I can substitute this now, so it will be 2 times this. Equals to p. So log x base a will be p minus this term, so minus 4p minus 2q over 7. Now be careful when you combine the fraction. So it will be 7p minus 4p minus plus 2q. We will have this in the end, 3p plus 2q over 7. So following the question wants this term, so we copy down log 1 over square root xy base a. Okay, so each time we see such a complicated term with a logarithm, so just like the first two equations, we will try to use logarithm rule to break them up into a sum or difference. So this is a quotient form, so it's a difference. But we can express this using index law. So this is actually simply just log xy. Right? Since the square root applies to both x and y, so it will be negative half. So bringing down the negative half power, I'll get this term. And following logarithm rule of the product, so product means they multiply, to the individual logarithm terms will be, index form will be adding, so it's a sum of both. So minus half log x sum, so plus log y base a. So expanding, then you can substitute the log x term in terms of p and q, and the log y term in terms of p and q into the final part. So log x base a is this, so I'll substitute inside here 3p plus 2q over 7 minus half times log y base a term in terms of p and q is here, so 2p minus q over 7. Right. So simplifying carefully, so you should get this term here. Then you finally express term again, x1 over square root xy base a as minus 5p minus q over 14. Right, or you can just simplify it like this way, 5p plus q.